So
quickly, good afternoon all. Welcome to TechTalk session on WebSockets and its applications in telehealth. This session will be taken by Prasad and Sri Satya, who are from NetSmart team. Over to you, Prasad.
sure. Yeah, thanks for the introduction. So yeah, welcome everyone for the Tech Talk today. So we are going to talk about the WebSocket implementation in telehealth. So basically, what in an overview, in a nutshell, what we are going to do is like we are going to look at a problem that we faced in telehealth, right? And how we overcome that particular problem using WebSockets, and what were the alternatives that were there in front of us, and what advantage WebSockets gave, and how we use that to overcome the issue. So this is at a high level that we are going to look. So I am just going to share my screen now. So is my screen visible?
Yeah.
Okay. So before we go over to the, one second. Yeah, so before we actually get into the problem, I would like to just provide a quick overview of the architecture that we have in telehealth, right? So if you remember last year in April 2021, we had a tech talk session on telehealth in which we had a deep dive session on the architecture of telehealth, what were the different components that were used, and how we are able to create virtual meetings using Amazon Chime. Like at the end of this session, probably we will share a link to that particular recording as well, so that for the benefit of those who didn't attend the earlier session last year. I would like to give a quick overview for the benefit of all of us, so that we can dive right away into the context after this. So in telehealth, so we have to give you a tech overview of the tech stack. We have AngularJS, we have TypeScript, we have RX Java, namely Vertex. We also have JAX-RS based microservices which run in the backend, and there are and all these services are containerized. So which means like they are running in Docker containers in AWS ECS, Elastic Container Service. If we look at this architecture diagram, you can see that a user can log into the telehealth application UI, and then he gets to do various things like create new appointments, right, and then attend meetings and all. So all the calls from the UI to the backend services are routed through the telehealth Vertex layer, right? And then like various functionalities that we provide are like create new appointments, and then we also have Lambda jobs running at pre-configured intervals, which will actually pick up the appointments that are there in the database and send out notifications. So basically, at a high level, if you see, we have got two purposes in telehealth. One is to create appointments, right, and then schedule appointments. We can schedule appointments for any time. You can even schedule appointments that run immediately. We have the meet now functionality, and we also have the functionality to actually attend the meetings. So we have this telehealth meeting UI using which you can attend meetings, just like we have in Zoom or Google Meet or any other application. That is the functionality of telehealth at a high level. If you see, we have used Postgres SQL backend, and we have used various microservices. Some of them are in-house, meaning telehealth specific. Some of them are common platform microservices, which are used by different applications, right? So yes, this is a overview of telehealth architecture at a very high level. Okay, so like any questions till now? Okay, Okay, so we'll dive into the problem statement right away. So what and let me just read through this problem statement. So in the telehealth application, a notification that is in the form of an SMS or email is sent out to the participants with the link of the meeting just 10 minutes before the start of the scheduled start of the meeting. So yes, so what happens is, for example, if we have a meeting at 3:30 p.m., a notification is sent out either SMS or email to the participants with the link of the meeting, right? So, and once the participants receive the meeting, they can click on the link and they can go and actually, if they are just participants, they will be taken to a waiting room where they will be waiting for the doctor or the provider to actually start the meeting, right? So if in case the links are sent out to the doctor as well as the patient, so when the doctor clicks on the link, we actually create a chime meeting in the backend, and then we for the patient who is waiting, we automatically transition him to the tech check screen. In the tech check screen, what happens is both the doctor and the patient, they can choose the devices, they can test their audio and video devices, check if the internet is stable, and they can actually get into the meeting right away, right? So if a patient clicks on the link first, as I said, he or she will be directed to a waiting screen where there will be stationed till the provider clicks the link and initiates the meeting. When the provider clicks on the link, a chime meeting is initiated in the backend, and the provider is redirected to the telehealth tech check screen. Immediately after this, the patient is also redirected to the tech check screen, right? The coming is okay. So this is the user experience. So what is the technology that runs this whole thing? So the communication between the front end UI and the backend services is handled by RX Java using the Vertex event bus. So what happens is, like, we have this RX layer or the Java RX Java, which actually has this component called uh, event bus. So what this event bus does is it can send out events. Look, when a provider actually joins a meeting and the meeting is actually created, what we do is we call the Chime API to create a meeting. We fetch a number of details that Chime provides in the response, and we update those in the table. So immediately after we update the meeting details in our table, we send out these events through the event bus. There are clients who are actually subscribed to these events from the UI, from the Angular front end. So automatically these clients will start receiving notifications that their meetings have started, right? And then they will be automatically be redirected to the tech check screen, where they can do their initial check, as I mentioned. Okay, so this okay when we tested this in our development environment, or in our QA environment, right, till UAT, we didn't face any issues as such. This technology was working, this architecture was working perfectly fine. We didn't find any issues, right? So everything was hunky dory. So even if, after it was deployed in production, everything was going on very smooth until suddenly we started noticing some issues in production. So what happened was, when there is a lot of load in production, right? So our clients are based out of America. So especially during US time, after evening 6 o'clock or 6:30 our time, when the people start, when the clients start using our system more, both the doctors and patients, the load on the system increases. And at that time, what happens is, lot of we got a lot of tickets saying that these patients who are in the waiting room, they were not getting automatically redirected to the tech check screen, right? So we started getting these issues just in a trickle, like one by one, and gradually over a period of 2 to 3 weeks, it started piling up, and we got more tickets saying, this the automatic redirection is not happening. Okay, so under high volumes in production, the events sent from the backend upon meeting creation not received on the UI side. consequently, the patient was not automatically redirected to the tech check screen after the meeting was initiated by the provider. The provider kept waiting for the patient in the telehealth meeting, and on some occasions, the patients, did join the meeting, but before that, the provider would have quit the meeting, right? So what happened was it led to some sort of what to say, destabilizing experience on the user usability perspective, because doctors they had started the meeting, they were waiting for the patients to join, but the patients never joined. This was simply because the patients did not know that the meeting had actually taken place, right? So there were a few issues that were reported like this, for maybe a couple of days, right? So we like tickets were raised to us, and we started looking into what the issue was, right? So we found out that these okay, so on investigation we found out that these events were not being sent properly from the backend, the microservices layer to the vertex layer, right? So the events were not properly sent to the event bus. So we figured out that this was the root cause of the issue by looking into the logs, by looking at the CloudWatch logs, debugging, adding more logs, trying to pinpoint where exactly we could go wrong. We figured out the root cause. What was the issue behind this problem? So we had in conversations with different client teams, and we also had internal discussions within Ideas2IT. We reached to different teams, reached out to different teams, and got their suggestions. The way they have implemented similar solutions and all, right? So so from a team we got that they're using server side events, right? But again, server side events was working fine for them because they didn't have a huge load, right? So it was untested from that perspective, right? But but our problem was different because we had a lot of volume to handle, right? So what we did was, as an interim solution, we configured a property in our database to initiate long polling from the client side. Just to give a quick overview of what long polling is, there are different polling strategies, right? One is a normal polling called short polling. The other one is long polling. So what happens is, like in short polling, we initiate a request from the front end, HTTP or HTTPS request for security, and then from the client to the server has to immediately respond, and then the client will send the next request and so on. So this is a short polling. So long polling is slightly different. What happens is the client sends out a HTTP or HTTPS request, and then the server doesn't respond immediately, right? So the server holds the request or holds the thread for some time, right? Till either it has the response to give, or till the actual request times out. Till that point, the server holds the thread or holds the request, and then it gives a response, right? So as an interim solution, we had this in place. We implemented this quickly over 1 or 2 days, and then we had this configured for each kind of user within this particular application. And then we like what happens is, as part of this long polling, we initiate a request from the client to the backend. There is a service call that goes, and then we get a response. And once we get a success response, we automatically transition the client to the tech check screen. So this we configured to run at periodic intervals, maybe like once in 20 seconds or once in 30 seconds, to ensure that the automatic transition happens, right? This was the interim solution we put in place. The one drawback or one trade-off that we have, right? So in architecture, as we say, like we cannot have a perfect solution from all aspects. There has to be trade-offs at one place or the other. So the trade-off that we had to do at this place was actually we had to make more calls from the UI to the backend, which actually could have a potentially hit on the performance, right? So that was something we had to actually look into, and then we carried on with this as a interim solution, right? But after we implemented that interim solution, we were able to have a better user experience. The patient was actually able to automatically transition from the waiting page to the tech check screen, right? Okay, so I see Kalpana is raising her hand. Kalpana, if you can ask your
Yeah,
question, please.
just one question. So you were talking about like load, right? So what was the load actually that we were like trying to target here?
Yes, the thing was, there were around, I would say, like maybe 10,000 requests concurrently that were happening.
Okay.
Okay, so yeah, so when it was not 10,000 meetings per se, Kalpana, so this event bus was used in different places within the application, as in like whenever there is an event that happens in the service or backend side, we used to communicate using this event bus to the front end. So
Oh,
that, yeah, so that happened within the application. For example, provider will have access to the dashboard, telehealth dashboard. So whenever a patient joined, right, he would get a green signal or green, he would get a green light on the left side of the screen to indicate that the patient has joined, right? So he could click on that join visit button from the dashboard itself and join the meeting and initiate the meeting,
okay.
right? So if we consider that there are lots of meetings, a doctor can have up to like 20 meetings, 10, 15 or 20 meetings a day. So he will be getting lots of events for all these meetings. And if we look at a staff admin from a hospital perspective, like he or she will be getting lots of these events for the various doctors who are working for that particular hospital, right? So
Got it.
yeah, so there was an exhaustive use of Vertex event bus in this scenario, and apparently we found that at some point it started breaking, and it could no longer handle the load that we expected it to. So that's
Was it because of the limitation in the Vertex event bus?
yeah, exactly. So
Okay.
we actually did a lot of research, and from the Vertex like manual or the documentation itself, we found that Vertex offers only best case delivery. So
Mhm.
it doesn't guarantee 100% delivery every time.
Okay.
Okay, right. So that was sort of eye opener for us at that point. Uh, so we wanted to think about different solution. Obviously, we had to come with a different solution to circumvent this particular issue. So as an interim solution, we put this the long polling in place. Okay,
Got it.
and the user experience started improving, but at the same time at the back end we realized that there are more calls that are going in from the UI to the back end, and the network resources are also getting more consumed a little more, right, than expected, right? Still we haven't hit any roadblock, but uh, this is not the ideal place to be in, right? So we started digging into other solutions which could be a permanent sort of solution for this particular problem, right? So yeah, let's look into the
Was
solution
there,
that,
I mean,
yeah,
if we had not proposed Vertex, I mean, if we have done the re-architecture, what would have been the best solution?
yeah. So we are coming to that, Kalpana,
Okay, got it. Thanks.
right? So yeah, Shahul, I think you're raising a hand, Shahul.
Yeah. What I want to ask is, you told that you went for the long polling. That means from the back end, the request went to the front end. This is right, right?
Uh,
In the previous schedule, you have mentioned that there was a polling, and from back end, the request went to UI.
right.
So, so
Hmm.
in the later part, you mentioned that you have used long polling. Is it that previously have you used a short polling, or later you went to long polling? Is
So
it
yeah,
right?
yeah. So giving you the sequence of events, right? So initially, we use the Vertex event bus, right? We use the Vertex event bus, and so the Vertex event bus, what internally it does is the flow of Vertex event bus is like this. So from the UI, like clients subscribe to this event bus to receive events. Okay, So what happens is from the backend, when a particular event happens, right? Events are sent from the backend to this event bus, Vertex event bus. The clients pick up that this particular event has happened. They will receive this response object, and then we will have the logic in the UI to transition them to a different page. So that was the existing architecture. Okay, that was Vertex event bus.
Okay, but here you talk just backend and UI, right? So backend and front end. Can you consider like that?
Yes, yes. So the UI is the front end. We also have a middleware layer called Vertex Java, RX Java. So all requests from the UI to the backend services or microservices are routed through the RX Java layer only. There
Okay,
are
the
no direct
middle.
calls. Yeah,
So from middleware only both the backend and the front end communicates. So
exactly,
what are
exactly,
the events comes the backend sends to the vertex and vertex communicates with the UI. So here the problem was the vertex event sent to the front end was not received by UI, is it? Or the vertex didn't send the event to the UI.
The Vertex did not send the events to the UI.
This is because it has high volume of events, is it?
Exactly, exactly.
Okay. That means it is not able to scale it.
Exactly.
Scalability was a problem.
Scalability was the problem.
Okay.
And when we digged into the documentation, it itself very well told that it was a best case delivery that it could offer, and it was not like 100% guaranteed delivery. Okay. Uh, yeah, quickly moving to the WebSockets, right? We will actually do the session. Thanks for the questions. We'll just move ahead quickly, and we will have Satya is also going to explain the architecture of the solution and everything. So at the end, hopefully, like we'll have some few minutes, at least some 10 minutes, where we can take your questions and answer them. Is that fine? Okay. So yeah, what are WebSockets? So the solution to this is WebSockets. So what is WebSocket? HTTP based APIs use a request response model with the client setting a request to a service and the service responding synchronously back to the client. So this is a HTTP based model which we discussed. So what is the difference between a HTTP based API and a WebSocket API? So WebSocket API is an advanced technology designed for a two-way communication between a web server and the client's browser. So what happens is there is a persistent connection, or they call it full duplex connection between the client and the server. The client sends a request to the server, and the server receives the request. We receive the request, store it in some place. Okay. In our solution, we have stored it in a DynamoDB database. So yeah, we'll come to that in the next slide. So what we have, and whenever we receive, whenever some activity or the event has happened in the backend, this server component is going to send a request or a response back to the client over the same connection. Okay, so there is a single connection in which both the client as well as the server can use for communication. Okay, so in the case of HTTP based communication, we have almost like we have just a one communication, one connection, right? So the connection can be either from a client to server initiated, or in case of server side events, it can be initiated from the server to the client, right? So and the connection gets closed immediately after the request response is over. But here we actually have this persistent connections in place in which the request can be sent and the response can be sent over the same connection, over a period of time, so it doesn't get closed immediately. So that is a difference. WebSocket APIs are bidirectional in nature. That means a client can send messages to a service, and the service can independently send messages to its client over the same connection. WebSocket is an alternative to HTTP communication on the web, allowing you to send messages to the server and receive event-driven responses without having to wait for the server to reply. Right. This is what we said. WebSocket provides a persistent full duplex two data communication with a low latency rate. Right. So the latency is very, very low. So especially in our scenario, when we have a huge load in place, right, and when there is a lot of traffic, we want to ensure there is absolutely low latency, right, and the user experience is not impacted. So that's where WebSockets really help. And WebSockets establish a persistent connection between the client and the server, and both parties can start transmitting data at any time. In AWS context, we can build bidirectional communication applications using WebSocket APIs, Amazon API gateway, and Lambda functions without having to provision and manage any service. So as I said, like our application is entirely hosted in AWS, is built on AWS using AWS components. So here we have achieved this WebSocket communication between the different components of the application using WebSocket APIs, Amazon API gateway, and also Amazon Lambda, AWS Lambda, right? So uh, yeah, this is about WebSockets, right? So any questions till now? Any questions? We can I can take a couple more questions, and then I'll hand it over to Satya for her. She'll explain the architecture of the solution and other things. Any questions?
Hello.
Yes. Yeah.
This is Shahul. He told that here the WebSocket is going to replace the Vertex, right?
Correct.
Or still, so he told that Vertex is an even bus, so WebSocket it also act as an even bus? Not
No.
like that, right?
No. So I will like when Satya explains the architecture and everything, like she can, you will get all your questions clarified. Right? What is the difference? How we have implemented?
Okay.
Yeah. Cool. Yeah. Thanks everyone. I'll hand it over to Satya to explain the architecture and take you through the next part of the presentation. Thank you. Satya, over to you. I've stopped my share.
Thanks, Prasad. Hi, everyone. Shri Satya from Telehealth team. I'll be sharing my screen. Is my screen visible?
Yes, Satya, it is visible. Probably, you just need to get a little louder. I think.
Okay. Am I audible now?
Yeah, it's better. Yes.
Okay. This is the architecture diagram that for a solution for which we have implemented a WebSocket API gateway, the clients will be invoking the WebSocket API gateway the connection. Once the connection is established, the certain events will be triggered, such as the connect, disconnect, and many such user-defined events will be triggered once the connection is established between the clients and the WebSocket API gateway.
Hello. Sorry, Sri. Sorry to interrupt. Your voice is very low.
Is it?
Yeah. I think. Yeah, now
It's like you're speaking loudspeaker.
Check.
It's like you are far away from the mic. So.
Am I audible now?
Yeah, now it's better. Sri. Yeah. Thank you.
Sorry about that. So I'll start from the beginning. We have used WebSocket API gateway provided by AWS services. So this is for the WebSocket, establishing the WebSocket connections between two different entities. So the clients will be invoking the WebSocket connection to the WebSocket API gateway, and once the connection is established, certain events like connect, disconnect, and user-defined events will be triggered, and the client handler Lambda function will be handling those such events, and will be storing the connection-related data in the DynamoDB that we have used. Also, the server-side events will be published from our telehealth service, and it will be sent to the meeting event lambda function, and this lambda function is responsible for processing the events and fetching the connection details from connection details such as the connection ID, the connection ID or the details that we get once a particular connection is established. So we need that particular data connection ID to post those events to the clients. So we'll be this lambda function will be fetching those connection related details from the from our DynamoDB table and post the events. I mean, publish the server side events to the clients through our WebSocket API gateway. So the API gateway will take care of delivering those events to the clients. So this is the architecture diagram for the solution.
Yeah,
Any
Shahul,
questions?
to answer your question, right? You asked a question earlier whether you are using the telehealth service. So this telehealth service is what you see, near the number 4, right? So the telehealth service, it sends events. So earlier we used to send it to the Vertex event bus. Instead of that, we are sending these events to a Lambda, right? If you see, this meeting event publisher is there. It's a Lambda function. So this Lambda function is going to receive this events from the telehealth service, and it is going to match these events with the clients who had requested for this information. So this mapping data is stored in the connection store that you see, it's a DynamoDB, right? In DynamoDB, we have stored this connection information where we have this mapping between the events and the connection IDs, which refer to these clients. So after fetching this information, this meeting event publisher is going to publish the events to the corresponding clients, right? Just expanding on the on her explanation. So since it is Lambda, right? So we always know that this Lambda is going to it is highly scalable serverless solution, right? Service. So Lambda as well as DynamoDB. So DynamoDB, as we know, it's a NoSQL data store. So we will not have any scalability issues, right? At the same time, Lambda is very reliable. It can handle those events, and then it can and it can intimate the corresponding clients, right? That the whatever information they had requested for has arrived, and it can send the response back to the clients. Shahul, hope your question is answered. Okay. So yeah, so the reason why we are going again for DynamoDB is because this is highly scalable. We are going to store information in maybe thousands, if not lakhs, of all the connection information, and there is no relational entities or relational data relationship between the data that we're going to store. That's why we've gone for like DynamoDB here.
I have a question regarding that. So will the connection information be persisted even after the client disconnects? Like, for example, you initiate a connection, the client is using the system, and then like imagine after using it for half an hour or something, they quit the session and then leave it. What happens to those connection information stored in the database? In the sense, in this case, NoSQL database. So my question is, wouldn't Redis cache more aptly fit here? Because essentially this is more like a cache of connection informations, right? So you can have eviction policies that automatically kick in after like half an hour or 1 hour, whatever timeout. So how are those information managed? Do we even evict those details from the database, or is it always persistent?
Right now, it is always persisted since we'll be needing this data for reporting purposes.
Okay, so you are auditing or using it for some kind of audit or reporting,
Yeah.
even the connections that have already been closed. Okay,
Yeah.
okay, and that's the reason why you probably would have chosen DynamoDB rather than a Redis cache. Okay.
And we also wanted this to be a store where later if we face similar issues, we could always go to the table and figure out right? Read B and figure out what were the connections that were established, disconnected, etc., so that we could troubleshoot issues better in the future.
Yeah. So yeah, if the intention is to persist it even after the connection is terminated, then yeah, definitely makes sense. Yeah.
Thank you, Andrews. Yes, Sri, can go ahead.
Sorry, I have one more doubt actually. Sorry, Sadhya, I just want to know, can you hear me?
Yeah.
Hello. Yeah. In this diagram, incoming events is coming. Right? For instance, a client is making some event means the WebSocket primarily will authenticate the user. Right? That information will be stored in the connection store. So uh, he told about that meeting, right? So for example, in Zoom meeting, when our client clicks, he will be moved to a waiting hall, right? Waiting room. So whether moving to the waiting room will be done from WebSocket side or from the client's incoming event side. That means from mobile or computer.
So initially the patient or the patient will be in the waiting room, waiting for the provider or the doctor to join the meeting session. So once the doctor has joined the meeting session, the meeting will be created and the response will be sent from the telehealth service to the meeting event publisher Lambda, and this Lambda will process the events and send the individual responses to the uh, clients who are all waiting for that particular meeting to be started. So
Okay, but
WebSocket
here mentioned connect disconnect events, right? So whenever the incoming request comes, whether the socket WebSocket gets created immediately or when that get created actually,
So
the connect event.
the connect event will occur whenever a new WebSocket connection is established between the client and the WebSocket API gateway. So in that case, the connection connect event will be triggered, and this Lambda will get the responses from the API gateway, such as the connection ID and the incoming client details. And this Lambda will store the connection ID as well as the user details in the DynamoDB.
So Satya, I think his question was rather like at which point in the overall flow does this WebSocket API kick in
Yes,
actually, right? So when
yes.
the patient joins the meeting, so when he clicks on the link,
Yeah, when the patient is waiting in the please wait, waiting room
No,
initially.
means when the user clicks that link,
Yeah,
at that point itself, whether the socket WebSocket gets created or
yeah.
when the user is moved to some waiting room, from that point, whether you create the WebSocket.
So when the patient clicks on the link, the first page you'll be seeing is the please wait page, which is the waiting room, and that is where the connection is established.
we actually transition him to the waiting room and immediately we establish a connection, Shahul.
So once he receives the meeting response, meeting details of Chime meeting through WebSocket API gateway, he will be moved to he'll be moved from the waiting room to the tech check screen, where he'll be able to check for the audio and video devices, and then he can proceed to join the meeting session.
Because you use the chime here for I'm not sure how the chime works. For instance, Zoom meeting, when I click the link, I'll be redirected to a page where the host is yet to come, like that room I'll be there, right? So that is similar to here. Here we come say it as a waiting room,
Yeah, yeah,
right?
yeah.
So that activity will be carried out by Zoom. So here that activity can be carried out by Chime. Then what purpose WebSocket does here?
So we cannot create a Chime meeting before the provider has joined, because it will take up more. It will cost us more. And also, let us say if the doctor has taken more time to join, the patient will be idle inside the meeting, and so it will be costing us more, right? So since there is only a patient inside the meeting, there is no point in creating the actual chain meeting. So before we create a chain meeting, we are just letting the patient wait in our waiting room. That is done through a Wrangler routing, not
So
through
the
chain.
waiting room part you're saying, right?
Yeah.
So that is a custom screen you're saying.
Yeah,
Yes.
the custom
That not a
Angular page.
Yes,
Yeah.
yes. It's a custom page, Rahul.
okay. So that is not an actual
AW,
chain AWS service.
no,
So
chain
once the
doesn't.
WebSocket gets
Sorry, chain doesn't provide a waiting room functionality out of the box. So we have implemented it through Angular. It's just a static page. I hope I answered your question.
okay.
I'll move on to the next slide.
Sure.
So secure your WebSocket API. So there are four different strategies that can be used to secure our WebSocket API gateway. So the first one is resource policies, IAM authorization, Cognito authorizer, and Lambda authorizers. So resource policies means you can have the policies attached to the API, WebSocket API gateway, and allow or deny based upon those policies. Allow or deny user connections based upon the policies. And IAM authorization is like user will be using their IAM credentials to invoke the WebSocket API gateway. And Cognito user pools, Cognito authorizer use the Cognito user pools, Lambda authorizer use Lambda function to perform the custom authorization that we need. So it'll be so this is an example of the resource policy. So the resource policy provides API-wide IAM permissions, which basically allows or denies specific range of IP addresses, or it allows cross AWS accounts to access your API gateway. So in this example, if you see, we are allowing the user Michael that is residing in this account ID, account underscore ID, account / ID to invoke this particular API gateway. So this is a sample resource policy that has been applied to the API gateway. So the next one is the IAM authorization. So IAM authorization requires all the requests to be all the requests sent to the API gateway to be AWS signature version 4 signed, and it is basically SHA-256 algorithm, basic 64 encoded using a SHA-256 algorithm with AWS access and secret keys. So it basically allows or denies request upon processing those basic 64 encoded string. And so if a user doesn't have a proper IAM permissions, then the API gateway will deny the connection establishment. So the next one is the Cognito authorizer. So Cognito is an AWS application security managed services, which allows the user to sign in, sign out, change their password, which is basically user management services provided by AWS. So whenever the user logs into the Cognito, it gives the JWT token. The user takes the JWT token and appends it in the header in all of the requests that he is sending to the API gateway. And this API gateway will talk to the Cognito and Cognito will take care of validating that JWT token. So the next one is Lambda authorizer. So Lambda authorizer is a most flexible authorization method, and API gateway invokes the Lambda authorizer, and Lambda authorizer is a Lambda function which performs custom authorization. It takes any data like username, password, or auth token, or any information that you pass in the request, and the API gateway will take those information and pass it on to the Lambda function. So the Lambda function is responsible for performing the authentication. So that it can talk to your DB or DynamoDB table, or any custom identity provider. The most used use case will be they'll be using the auth provider to validate the OIDC token. So this is an example. I mean, this is a screenshot of how you can create a Lambda authorizer. So I'm creating a Lambda authorizer with the name my Lambda authorizer, and mapping the API Lambda authorizer Lambda function to this authorizer, so that this particular Lambda function is responsible for validating the data that is passed through. So identity sources should be mentioned, because those data will be taken from the incoming request, and the API gateway will identify those data and extract those data and pass it on to the Lambda authorizer. So that Lambda authorizer function can process this data, it can go and verify it in your DB. So in here, I have mentioned it as there will be one header name called my custom header, and a query string will be passed called user ID. So whenever we pass a query string, user ID is equal to George, and his password in the custom header section. Those two details will be passed on to the Lambda function to validate. So that's it about security. Here comes the route.
Okay, just one point, Satya, before we proceed. All these services that we have used, right, and the protocols that have been used here, like they have been recommended and defined by AWS themselves, right? So like in the references, we have mentioned that there is one of the blogs which has been published by AWS, in which they have defined a reference architecture for using WebSockets, right? So we have followed a similar approach, in our implementation as well. So yeah, just a call out. Yeah, thank you. Proceed, Satya.
Yeah, thanks. So I just want to mention one more point. So if we are using any of these methods, and the incoming connection establishment request should be validated through any of these strategies, and once the API gateway gives a go ahead for the incoming request, then the connection details will be generated, like connection ID, and it will be passed on to the Lambda function, Lambda handler, event handlers. Only then the events will be handled. So if the authorization is failed, we will not be able to send the events to the clients. So that is about the authorization. So coming on to next topic, routes. So we have different route events. Yeah, this is. Hello. Okay, so we have a different set of route events for the WebSocket API gateway. So the first one is the connect, $connect. So this particular event will be triggered whenever a WebSocket connection is established, and a $disconnect event will be triggered whenever the connection is disconnected, either from the API gateway side or from the client side. And default is just a default route whenever the route path that is defined in the API gateway doesn't match with the incoming route path doesn't match with any defined routes, API routes. So, and then the custom routes means user can define any number of custom routes that can be used for business purposes, like sending and receiving messages to and fro between the clients and the server. So, so this is just a sample JavaScript code for establishing the connections from the client side to the WebSocket API gateway. So we have used a plain WebSocket API that's available in JavaScript, and we have connected to this particular API gateway. So once the API gateway allows the or authorizes the connection, we will be receiving this particular on open event in the UI. So we can have the logics, whatever logics that we need to have upon WebSocket connection open. And the on close event will be received in the UI whenever the connection is getting disconnected. And the on message event will be received whenever the server is trying to whenever server sends the events from backend to the clients. So the clients will be receiving the messages using the on message event, and the client can also send messages to the server using WebSocket.send method, so that this message will be sent to the API gateway. Any questions?
Yeah. Hello. Satya, can you hear me?
So
Yeah, here WebSocket.on open, right? So internally, whether it pings at server or client.
So sorry.
Because whether the disconnect event or on close event automatically calls when that response is not got in the on open event. Whether it have any duration for that. For example, within 5 seconds, if you don't get that reply back from that client, that on close event automatically calls here.
I think there is some timeout that is there in the WebSocket API gateway. So upon going past that time, we'll be receiving the on close event. And if the connection is idle, so if there is one, I'm not sure about the timeout seconds. I will check and let you know after some time.
What are the possible things that on close will get automatically called over here? Whether it happened in your testing?
Can you come again? There is too much background noise.
The on close event might have called automatically, right? So apart from the disconnect event can be occurred in any scenarios.
Yeah. So yeah, if the connection was idle for more than half an hour, I guess. I'm not sure. I'm sorry. If the connection was idle for more than 5 minutes, the on close event will be triggered.
Whether it will try to reconnect again, or once the on close event is called, that's it. The connection gets disconnected.
Yeah,
Whether the loop should start again.
We can write the reconnecting logic inside this on close event. If you are okay with
the loops, right?
Yeah, it just if you you can directly disconnect WebSocket dot you can directly disconnect the connection using WebSocket dot disconnect method. That is sorry that I didn't mention it here. So if you're disconnecting it, you should have a flag, like no need doesn't need to be reconnected. You should have a flag here saying that it need not to be reconnected. So if you're checking that flag value here, if it has to be reconnected or not, you can always reconnect to.
Yeah, what you're talking is that manual disconnect. So if any scenario, if the communication between the client and the server gets disconnected in the socket, whether the automatic reconnect happens here, if that means whether it ends up in loop or if you don't do that automatic reconnect.
It won't do the automatic reconnection unless you manually add that code in this block, in on close block. Until we add that automatic reconnection code, it won't happen. Once the connection is disconnected, that's it.
So his question is right, Satya. What he's asking is, so let's assume that we have a timeout period beyond which this disconnect event gets fired and on close happens, and then the connection gets disconnected. So after that, if the client has not received a response from the backend, even after this disconnect has happened, what will happen? Will it the client and again initiate a new connection, WebSocket connection?
Yeah, the client is responsible for creating the new connection.
Right.
There won't be any auto connection, auto reconnecting.
Yeah. So Shahul, like obviously, we don't want to have idle connections hogging the AWS server for a long time, right? So we do have a time beyond which we will actually automatically disconnect this connection, provided it's idle, right? So yeah, we have done that configuration, and when if we have the client does not receive a response within that time, then the client's responsibility is to initiate a new connection to get the desired response.
Okay, thanks for that.
Yes, Satya, you can proceed. Yeah.
Okay. So this is a sample Lambda handler function for handling the connection related event loads. So whenever we receive a event with the $connect, we will have the logic here. We'll have the business logic here. It will be handled. And whenever we receive a dollar disconnect event, we should have a business logic for disconnecting, or we can go and delete that particular connection details from DynamoDB. That is our wish. So also, whenever we receive a message from the client to the API gateway, so the message can be processed here. And by default, if the incoming route doesn't match any thing, this dollar default route will be called, and you can send any response back to the 400 response or something like that to the clients. This is a sample handler function for handling the meeting events. I mean, sorry, the connection events. And moving on to the Lambda function, sample handler function for posting the server-side events to the clients. So we'll be receiving the server-side events in this handler function, and we will have it as in here. I've just set a message called hello from API, and I've set that payload data property, and connection ID is the mandatory property that needs to be set, so that API gateway will know to which client this message has to be sent. So the connection ID property is mandatory. So and this payload will be sent to the client through this post to connection method that is available in the API gateway.
So the const payload here, right, which we have hard coded, could in a real time scenario, it could be a message that we receive from the backend.
Yeah, so we can process the incoming data received from the backend and send that data to the UI along with the connection ID set.
Right.
So, and we will send the response of 200 message posted to the server backend server, which has invoked this event. Like the API gateway has sent out this message to the client like that. So we can send back the response as well. And moving on to the next slide. So the real-time applications of the WebSocket API gateway can be chat applications and stocks, crypto trading applications, and gaming applications, which will need real-time information with low latency, which I mean applications which need not wait much longer to receive the actual data. So those applications can make use of the WebSocket AWS WebSocket API gateway. So I've mentioned some of the references in there as well. Any questions?
Hi Satya, this is Jaraman. So I have a question.
Sure.
Yeah, I got the meeting link 10 minutes before the actual meeting starts. Okay, so I've joined the link and the WebSocket API's connect is fired, and only after the 10 minutes the meeting will get started. So you said that after 5 minutes of idle time, you're disconnecting the connection. So, what happens in this scenario?
So to overcome this scenario, we have sent a custom message called ping from the client to the API gateway to just to keep the connection alive. So it will be sent. The ping message will be sent every 30 seconds to just to the API gateway from the clients just to keep the connection alive.
Okay, so even if the doctors or the provider he opens the meeting late, so the ping message will keep our connection alive. Is that what you're saying, Satya?
Yeah, for our reporting purposes, we kept the connection open till we end the meeting session. So that is purely for our reporting purposes. But we can disconnect the WebSocket connection whenever our necessary data has been received to the clients.
Okay.
So to keep the connections alive, we have sent that ping message every. Any other questions?
Hi Satya, whether this ping will be a two-way communication or it will be from server to client?
We kept it as one way, although you can have it as two-way. Let's say you send your ping from client to API gateway, and then your Lambda function receives that message, and it can send back ping receive or ping pong message from client to from Lambda to your client via post to connection method. You can have it as two-way as well.
Okay, so means you need to set any trigger like let's say the meeting is going to start after 10 minutes, so keep pinging up to the 10 minutes or the meeting time like that.
It is not a mandatory 10 minutes gap. So whenever the doctor will be able to see that the patient is waiting using their dashboard where the doctor will be able to see who are all waiting in the waiting room and in which meeting he has to join. All those information will be displayed to his dashboard. So that is a separate functionality. So whenever he wishes to join that particular meeting, he'll be able to join the meeting. So it is not mandatory for the patients to wait for 10 minutes. So if the doctor is free even 5 minutes before the actual meeting start time, he can hop onto that meeting and the meeting will be initiated.
Okay.
So once a meeting is initiated, this WebSocket gets disconnected. Hello.
No, as I said, we kept the WebSocket connection open until the meeting gets ended by the doctor. So, so we
Because
will.
Chime is video conferencing tool, right? So
Yeah.
like a Zoom, we can have a chat there itself. Then why this WebSocket still need to be connected there?
So a chat functionality is between the meeting attendees, right? So the chat functionality will not be for the server side and the client side.
Here, if you look into the Zoom, we have a chat functionality here. So whether the Chime will be same like the Zoom or it's not like that. We can't have chat functionality in Chime.
We have implemented chat functionality inside the meeting session in Chime.
Okay,
So
so
that
we
is
have the
yeah,
functionality.
that is inside the meeting. Once you join the meeting, they'll be able to chat with each other, right? So we have certain restrictions with respect to chat. Only, I mean, the doctor will be able to. I mean, even the communication can be only between, the doctor and the patient, right? And a patient cannot see if it's a group meeting, right, or a group consultation session. Then a patient cannot see who the other patient is, right? So we respect the privacy, and like we have implemented our application in such a way that there is complete isolation in terms of the messages and the views that each patient can see.
So here you're saying that you can receive messages through Chime and also through WebSocket, right?
Shahul, to differentiate between the two communication inside the meeting session, the chat will be happening between the attendees, right? So I can say hi, you can say hi. So that
Yeah.
is a
So
text message that you're sending to other attendees. What?
yeah,
Uh,
that is the
but
chat conversation, right?
yeah, that is the conversation that we have implemented using Chime. Once you are inside the meeting session,
Hmm.
but if let's say I have to send some other response as well to the attendee, or I have to keep track of the user's meeting session as well, right? So uh, uh, we kept the connection open for the just purely because of the meeting statistics data, and how long the meeting has taken, how long the patient has been waiting, how long the meeting has happened, when the doctor has joined, and when the doctor has dropped off, and all those data. So we need all those data for our reporting section. So we kept the WebSocket connection open just to track all those data, and we'll be storing it on IDE.
To just add
Okay,
to it.
so once the Chime meeting ends, so go ahead.
Yeah, just an example. Probably if people have used Practo before, you would have seen the exact same thing that Satya was saying, that like when you start your consultation in Practo, mostly the doctor will be doing more consultations in parallel, or he'll be actually looking at a physical person in his office. So he may reply you within the chat saying that can you give me 5 minutes, or can you give me 10 minutes, but that will not be part of the actual chat application, but that will be part of the communication that could potentially be done through WebSocket. And then the actual consultation starts from within Chime, as you said. If I'm correct, Satya, is that what you're trying to say, right?
Yeah. So I can explain it in a real-time scenario that is happening in our application. So let's say the doctor is busy, that he has to attend another emergency case. He will drop off from the meeting, and the front desk staff who has access to all the meetings will see that the patient is waiting without the doctor in this particular meeting, and the front desk staff will assign another doctor uh, for this particular meeting, and the second doctor will be able to join the meeting. So all these details has to be tracked for our business logic, for our business purpose. So we use this WebSocket connection that has been already initialized, just to keep track of whoever is active in this meeting session, who are not active in this meeting session. All those details will be tracked, and we use this information to other features, like assigning another doctor to ongoing meeting.
Okay. When this WebSocket will get disconnected actually, when the doctor finish up this meeting or when the client disconnects.
Yeah. So let's say when I drop off from the meeting as a client, I should be able to drop off from the meeting anytime I want, right? So in that case, at that time, the WebSocket connection will be disconnected. Also, when the provider, as a provider, he will be the meeting host. So we have given him permissions to end the meeting session for all. I mean, whoever in the meeting will be pushed out of the meeting session. So when he clicks on the end meeting for all button. So in that case, all the WebSocket connections established for all the attendees will be disconnected.
No, you're saying two answers. You say that when the client disconnect, it will disconnect.
Yeah.
When the provider disconnect, it also get disconnect. Actually, if a client disconnects, whether the socket get disconnect or not.
So let's assume you and I are in the meeting. Okay. So you are the doctor and I am the patient. So if I say I want to drop off from the meeting, I can end the meeting, and once I end the meeting for my I can just leave the meeting, not the end meeting. I can just leave from the meeting, and my connection, WebSocket connection, will be disconnected. Okay, so I won't be receiving any future in server side events through that WebSocket connection, but the doctor will be able to stay on that particular meeting for another 30 minutes. So he'll be receiving the
Yeah,
future
but
income.
here the socket is like a two-way communication, right? So it's like a pipe between you and me. So if I
No, no,
get
no.
disconnected, then obviously socket get disconnected, right?
No. The
It is a
WebSocket
persistent
connection.
connection. It is persistent connection.
No, Shahul, the WebSocket connection will happen only between my browser tab and the WebSocket API gateway, and the server side, our backend resources will be posting the events to that API gateway. So it is a WebSocket connection between my browser tab and the backend server, not between my browser tab and your browser tab.
The connection still persistent. The only thing is you disconnect from that connection. Yeah, you disconnect that particular. So you are not connected to that particular connection, WebSocket API connection. But the API connection still persists. Right?
Or is it like there are two different web connections, like one from doctor to server and one from client to server?
Yes.
So that's why only one gets disconnected and other still remains active.
Yeah. If I leave from the
That
meeting, my
means
connection will be
the
disconnected.
provider can send the message to. Oh, that means still is two connections, right? Then still the provider can send the message to client.
I mean,
Client.
you mean the text message? that
Yeah, you said that what I assume is it's like a socket is a pipe connection where you can send the data at any time. So I have disconnected means the pipe get disconnected. But you say that still the client is not, the provider is not disconnected. That means he can still send the message, right? He can still buy the event
so
to the client.
so I'll tell you clearly. By the WebSocket connection, I mean the connection between my browser tab and the backend server. And when you join the meeting, you will have a connection, WebSocket connection between your browser tab and the backend server. So it is not a direct communication between you and me.
Okay.
So it's like I want to be receiving my user specific events from server. So it doesn't concern you. Those events doesn't concern you. It is user specific. So those events will be sent from server to my browser tab via API gateway.
Okay, sir.
Correct me. It's like a Google Chat. If means I am having a chat window open at my end, and you are having the same at your end. I'm closing it. That means I am disconnecting the event, but it's still open at your end, and you can still message me if you want.
The thing is. Let's assume you're talking about, okay, so you're talking about a chat application and it's a WebSocket API gateway enabled chat application. Am I right?
Yeah, I mean to say here that if the connection is still open at doctor's end, then at any point, if doctor thinks that I can ping this patient again, then he can initiate the chat again. Is that right? What I'm assuming?
So our
not exactly, in the sense, see, you said, right, you disconnected or closed your chat application from your side. In the sense, doctor can send the message, it will not reach you though. In the sense, you have disconnected the connection. So it's more like uh, multiplayer game, or the chat that you said, which is using WebSocket and things like that. Essentially, what they are having, or it's not a pipe connection where one is connected to a provider directly. The connection happens, the WebSocket connection happens from the client to the centralized server, in this case a WebSocket API gateway, and then also a connection happens from the provider to the gateway. So essentially, for each communication channel, there is two connections, that is potentially two WebSocket connections involved. So even if one is disconnected, the other one doesn't necessarily always disconnect. So other one disconnects as and when they disconnect, not necessarily because one of the end user disconnected, because he may potentially reconnect or something might happen. So it depends on our handling rather than essentially it's more like even in a multiplayer game, right? Like when you play 5-player together or something like that, one player disconnects, it doesn't mean every other player moves out of the game. So they still get connected, still be able to use the system. So the essential part is it's not one-to-one connection, as in one browser client WebSocket you establish to the provider's browser. So it's more like a centralized place where you have the connection and the data is managed, if I'm correct.
Yeah, to add on
Saying that
to
is
that,
sent what?
Okay.
Sorry.
to add on to that information, let's say I want to talk to you and I'm establishing a WebSocket connection. So, okay, the WebSocket connection won't be established between you and me. As Andrew said, it will be established between me and the centralized server. And you will be establishing your connection between you and your browser tab and your server. So if let's assume there is another user and that I want to talk to. I don't need to create another WebSocket connection, right? So I just have to post the messages to the centralized server, mentioning that this message is specific to this user. And API gateway will take care of posting that particular message to the user too. So if you are talking to 10 people, you don't have to create 10 different
Connections.
Connections.
Yeah, got it.
Prasad and team, sorry to interject, but like it was a great session. I think that it was an interactive session more honestly, like Shahul, a lot of people has stepped up, like, so I would say like, if you want to more the interest of time, we should do one more session or just a quick Q&A session as well.
Yes, Maharaja, we can do one. So we can have probably a demo session, probably followed by Q&A.
Exactly, just a demo and walkthrough so that people also participate and they get some experience.
Yeah, they can understand the application better, and most of the questions will not be like,
exactly. Chaitanya, yeah, definitely. Looking forward, yeah. So great show, Sri, Prasad team, great show. Second session, and it's been 1.5 hours, more than that, and people are still going strong. That means that much traction this product is.
Yes, so we will also share this, the recording of the earlier Tech Talk with the audience so that they can go through that and get a better context of entire telehealth.
We should.
Yeah.
We should
do that. And thanks everyone for your active participation. Thanks Shahul, thanks Andrews and other folks for your. It was very interactive, and you kept us on our toes, we should say.
And one good read for others, for some of you who are not necessarily into what tele health is or insights into the actual product, if you want to see or look at a general implementation, I think Slither.io was a game that made WebSockets predominantly used everywhere. Okay, so that was a developer who started it to begin with at home, sitting at home. He worked on it for 6 months, and then he just developed a simple snake game for a browser, and then he sold it for close to, I think, billion or something like that, $19 million, or I think close to $1 billion or something. So he predominantly came about using WebSockets for multiplayer games. So his system was scaling significantly in terms of like, even when there were 1 million users connected, he was still able to work it out and then get going. So that's when it kind of became super cool. And then a lot of gaming websites started using WebSockets, because every arrow that you press potentially has to be communicated to every other user connected, right? So it has to reach the server has to send it immediately to every other connected user. So if you want to read up about the implementation, probably Slither.io WebSockets would be a good read. So probably you can search it over there.
Sure. Yeah. Thanks, Andrews, for that snippet.
Yeah.
Okay. Yeah. Thanks everyone.
Thanks everyone.
Your active participation, and yeah, see you soon in the next session. Thank you, everyone.
Great, Prasad, Sri, and thanks a lot, Andrew, for supporting as well. Thank you. Okay.
Thanks, Prasad and Sri. Thanks, Maharaja. Thank you all, guys.
Wonderful. Thank you.
Thank you. Thank you.
Thanks.